Hello everyone. So in this tutorial, I'm going to walk you through the design of a two-input NAND gate. So I'm going to design a layout, but this time I'll not use a schematic driven layout. I'll not generate the layout. Rather, I'll draw the layout from the scratch. I'm going to access it remotely. So let's see how it works. Okay, to open the window, I'll use the command csh. Csh is after that source mentor.cshrc, then adk underscore ic ampersand. So this is the Pyxis layout window. So I'll select this new layout and then we'll give the cell name. I'll create one folder, maybe uh, demo 3. So in that, create another folder, NAND. Okay, so for process, so I'll use the same path $adk. After the technology, IC, process, and 180 nanometer TSMC, and rule. I'll find the rule here itself in the process. So this dot rules file, and in option I'll attach the library from the same path. Okay, so in this black window I'm going to design this layout. Okay, so for this so first I'll show you the schematic of this NAND. Okay, so NAND is something like this. So NMOS are connected in series. So if I so these are two NMOS. If NMOS are in series, so PMOS will be in parallel. So this is the connection. So this is input A, input B, and output is taken from here. So I'm writing O for output. This is ground. This one is VDD. Okay, so I need two NMOS, and these should be connected in series, and two PMOS, and these two PMOS should be connected in parallel. So to get the MOS device, I'll click here, or I can enlarge the window. So this is the one, add more devices. So if you click here, you can see here NMOS. So I can give the size. So for NMOS, L I'm keeping 0.18 micrometer and W 0.36. Okay, so this is one NMOS and this is another NMOS. Okay, now I need PMOS. So I'll select PMOS. The width of PMOS, I'm keeping it as 0.72 micrometer. Okay. It's not coming. PMOS. Yeah. Okay. So you can check it from here. I click on this, select, press Q. So it's a PMOS, and these are the L and W. And for this, select it, press Q. So okay, so it is still showing PMOS. It's NMOS actually. So convert it and size it accordingly, which we have decided. Okay. .36. You can get the information after pressing Q. Select it, press Q, and you'll get the information. Fine. Okay, so in this upper one are PMOS and lower one are NMOS. So we are going to connect these in this manner. Like the one of the terminal of NMOS is ground. That is source. Source is grounded. Then drain is connected to the another source of other NMOS, and the drain of other MOS is connected to PMOS, and output is taken from that point. So first we'll focus on this. And other thing like gates are connected. Yeah, gate of PMOS and NMOS is connected. So for for input A, we can connect these two, and for B, we can connect these two gates. Okay. So first I'll connect the gates, and I'll align them. So we'll press P. Okay, I'll extend it. So now I move this mouse. We'll select this, press them, and we'll try to align this. Yeah, so you can see it. Yeah, it's properly aligned. And what I'll do, I'll just overlap the things, like I'll overlap both the actives. Similarly, P. Now I align it with this poly. Select, press M. So I'll see whether it is properly aligned. So I'll zoom this. Yes, it's correct, I guess. and top also connected properly. Okay, so till now both the actives are overlapped and the gates are connected. So now I'll make the other connections. Like the source of first NMOS should be grounded. So as you know, the source and drain are interchangeable. So it will be easier for me to consider it as a source, because next I want to connect source of first MOS with the drain, drain of first MOS with the source of another MOS. So I can connect these two directly. These are nearby, so I'll consider this as a one first MOS and this particular point as a source of this MOS. So for that I'll press M. Okay, after that M. So up to this point I have made connection successfully. After that I'll make one out connection, so I'll do it afterwards. Now I come to PMOS. So in this both the source are connected and taken to VDD, and both the drain are connected and output is taken from that particular point. So maybe I'll consider these two as the source of both and will connect them and take it to the VDD. So M, again M. Okay, so now I want to connect these two trains. So for that I may connect it like this, or there is one beautiful way to connect it. Like I can use metal too, so I can connect it through this way. So as you know, metal 2 is at another level. So I'll show you how these works. See, this is the thing, like poly. After that, this is sky blue is metal 1, and this navy blue is metal 2. So these are on different level. So if you see the 3D diagram, so this is poly and this is metal 1 and this is metal 2. Okay, so I can easily like it is working as a jumper. So for my design, if this is one drain and this is another drain, so I can connect it like this. So I'll use this metal 2 and connect these via here. So this connection can be made easily. Okay, so I'll do that. Press M. So I'll change the property of this. This is metal 2 now. Yeah, fine. Now I place the wire to connect metal 1 with metal 2, because at the bottom I have metal 1 and over it I have used metal 2. So space PP. So this wire, space PP. So I have made these connections, but I left with this out connection, so I made this. So from the common drain of PMOS in the drain of MOS 2 and MOS 2, so I'll take this out. So this is MOS 2, this is NMOS 2, and this is the drain of this, and these are the common common drain for PMOS. So I'll connect these and we'll take output from here. So I'll use metal 2 for this. Hmm. So I'll change the property of this metal from 1 to 2, and you can see easily, like on the diffusion always there is a contact of metal 1, and over it now I'm using metal 2. So to connect these two I'll use a wire. So I'll press PP, I'll put this via here. Okay, and normally we should, I should check DRC all the times, like after every drawing I can check the DRC whether I'm violating any rule. So now if I'll check the DRC, so two error will definitely come, like uh, substrate contact is missing and PVL contact is missing, like that. So other than that I want to see whether there is any error or not. So I'll check it. It is processing. Okay, so there are two results. So you can see first one, the same thing it is saying that bad and well must have well contact. So that's what I told you. So I'll not bother about this now, because at the end I'll make this. Next, this. So other are clean. Okay. So we don't have any DRC till now. Okay. So, but here I would like to mention one thing. I would like to mention some rules at this technology. So, what is the minimum size of metal that you can draw, or what is the minimum size of poly that you can make on this? So, for that, like, on the right hand side, you can see there are many things like metal1.p. So, what is this? So this is metal 1 dot port. So if I'm making any port using metal 1, so I can use this one, and likewise these. And here these are simply metal 4, metal 5. Okay, metal 1, metal 2. So for these connections, I am using these metal 1 and metal 2. And for port, I'll use other thing. Okay, and for making PVL and well, I'll choose this and draw it accordingly. So how to draw these and what are the rules? I'll give you a quick review of this. So suppose I want to draw a metal 1. So I'll choose metal 1 and select this rectangle from the left hand side, and we'll draw it. So for that I'll zoom it first to see that those tiny dots. Yeah, so if I draw it here, so one, like two alternate dots makes one L. So I'm making it like this, one cross one L. So I want to know whether it is valid or not. So I'll see the DRC and I'll get the rule. So it is showing 4 results. That means errors. So first two are okay. So I will skip these two. I'm interested in this one next. Yeah. So here is the error. Okay. So it is showing metal width 3L. So that means these metal should have a width of 3L. So minimum I can draw a metal with these 6 blocks. Okay. So I'll, and what about poly? So if I click on this and I change the property of this metal 1 to poly, ULY, then I will see the minimum size of poly. Okay, again I'll run the DRC, check. Okay, so it is showing some 4 results. So skip first two. After that, third one is, yeah, something poly width should be at least 2L. Okay, so this is the rule for poly. So we have other rules as well. Like if you want to draw two metals side by side, so the spacing between two metals should be 3L if they are on a same level. Okay, and what about the distance between poly and metal? So there is no rule because poly is on another level and metal is on another level. So this doesn't make any rule. So I'll remove this poly and we'll move forward. So I'll select it and press D. Okay, and delete all TRCs. Okay, so next thing I'm going to make the ports like for input A, B, and for output O, and these power is VDD and ground. So for that I will make ports. Okay, so how to make these ports? So for that I'll again zoom this. Okay, so maybe I'll make one port here. So I'll use metal 2 for making ports and I'll press this rectangle. So as you know, minimum metal size I can draw is 3L. So I can draw a port of 3 cross 3, minimum 3 cross 3. So I'll start from here. So I'll count 6 block, which makes it 3L. 1, 2, 3, 4, 5, 6. So for safe side, I'm making some bigger one. Okay, so this is the one. So before using it, I'll check the DRC whether this port is correct. So two results, those are the previous one, not related to this. Okay, fine. So my port is correct and I can use it for various purposes. Okay, so I'll copy this and we'll use it for A, input A. Another one, I'll use it here. Keep it here. So this is for B. Okay, and for out O, I'll connect it here itself. Or I can use it. I can use it here for out. Okay, and for VDD, and for ground. Now all the ports are connected. A, B, output, VDD and ground. A, B, output, VDD and ground. Fine. Now I'll make the remaining connection. I connect it with the gate. Okay, and for this I'll put the via. Same here. And for this, these are also on different level. Poly to metal, so I'll put poly contact PC, which will connect vertically poly with metal one, space PC. Okay. Another one, another PC here. Okay. And here metal M. I can connect it this way. Okay. So here I no need of via because both are metal too. Both are on same level. Okay, so now I'll check the DRC. Fine. There is no DRC as such. Okay, now I'll make the N well here and P well here because both the because all the mosses are in well. P N moss are in P well and P moss are in N well. So I'll select well from here. Yeah, P well rectangle. Then N well. What happened? N well. Press rectangle. Yeah. DRC. Check. Fine. So I used to make VDD and ground these power rails somewhat bigger in size. So it has its reason because I want to make resistance as small as possible. Okay, so I make them bigger. I don't want any drop here. Suppose this is 1.8 I'm giving here. So I don't want it to get dropped from here to here. Okay, so I want to maintain the same voltage. So I make these somewhat bigger. So this is okay. So I'll select metal one to draw this. Select rectangle. So power rails. So this is VDD. And I copy the same thing and will attach on the ground port. 2. Now I'll check the DRC. Yeah, so I left with these two DRC which I want to clean. So I make N well contact and P well contact. So for that, space PWC and WC. Okay, I'll see the DRC. Check. One DRC is there, so we have to see what is the problem first. So it is showing contact to active must consist active to contact metal. So I'll remove this. You can remove this schematic first. It's not required now. Okay. So, okay, one more thing I would like to mention here, like the port which I made is made up from metal too, and this thing is this VDD power rail is made up from metal one. So, but both are not connected. So I have to put one via here. So I'll put that first. Okay, fine. PP. Fine, and I can shift it down somewhat. And same via here as well. Space PP. Now these are connected. That power rail is connected with port. So I'll run the DRC. Now zero result. So there is not any error in this. So DRC is clean now. Okay. So, but still, one thing is there. Like if you see the property of port, so this is one port. So I select it and press Q. So the layer name is metal 2. But for port, the layer name should be metal 2 dot port. So till now this is not the case. So I have to make them port. So how will I do that? I'll click on this. I'll right click and in add, I'll go to make. It's not showing. Okay, one second. Right click, make. In make port is there. So this is signal out. This is output signal out, and the name is I'm giving. Okay, out. OUT. Okay. Similarly, here also select this. Right click, add, make, port. This is signal in, and the port name is B. Okay. See, I'll do the same here as well. I'll select this, right click, add, make, port, signal in, and the name is A. Okay. And what about this ground and VDD? So I'll choose these, right click, add, make, port. And these are power in. Okay, and the name is GND, standard name. And here to first of all select, right click, add, make. Okay, power in, and the port name is VDD. Okay, so to get the name, I'll do the port text. Port text. So now here you can see VDD, A, B, out, and ground. You can zoom it and can see easily. Okay, VDD, A, B, ground. Okay, so the last time I would like to see the DRC, and then we'll close this. So it is clean. So after this, you'll do the LVS, then we'll generate the packs, and with these packs, you'll generate one netlist, and by using that netlist, you'll plot the waveform. Okay, and you can compare it with the schematic one. Okay, so this is it about drawing a schematic from the scratch. I hope you understood. Thank you.